Welcome to the Python Novice to Pro channel. Today we are going to talk about a SQL calculation that is very versatile, very interesting. That is inline calculations in SQL. I'm going to give you an overview of 5 methods that you can use for inline calculations. Now, you might say, what are inline calculations? Well, inline calculations refer to performing mathematical operations or aggregate operations on the fly within an SQL query rather than in a separate step or application. What this means is that when you're using an inline calculations, you're just performing the calculation on the fly instantly, dynamically, without you doing it on a separate application, without doing it manually. And you know what? Inline calculations are more efficient and they are more streamlined for data retrieval and data analysis. Now let me show you the 5 methods we are going to use to demonstrate inline calculations in SQL. First, we'll be using mathematical functions, aggregate functions, date calculations, case statements, and string functions. Stay tuned and I'll show you how we are going to do all of this. But first, I'm going to start with mathematical functions. Mathematical functions are your plus, your minus, your multiply, and your divide functions. In the database that we have to work with, the farmers market database, we are going to use only the multiply mathematical inline calculations. For example, if we go to the customer purchases database, you will see where we can apply mathematical calculations, inline calculations. For example, we could say, why don't we multiply quantity from the customer purchases database to the cost to customer per quantity, and to give us the price the price of each purchase. So let me show you. We want the price of each purchase. Let me bring up you can see the farmers market database is already open, so I'll just launch a new query window. So we want to get the price using an inline calculation. So I was taking it from the customer purchases table. So I could say something like this: select customer ID, product ID, quantity, and cost to customer per quantity. Then we want to get the price. Now we'll say quantity multiplied by cost to customer per quantity as price for each purchase as price. And we are getting this from from the customer from the customer purchases table, the farmers market schema, customer purchases table. So what is the price for each purchase? Let's see the price for each purchase. Good. Let me expand the window. So you see that for this purchase by customer ID 14, the price is 6.9201. The same customer ID, the price is 15.2382, and we keep getting the price for each purchase by each customer. That's for mathematical inline calculations. Now the next I'm going to demonstrate are aggregate functions. That is this here. Aggregate functions in SQL perform a calculation on multiple values and then it returns a single value. For example, we have sum, count, average, mean, and max. For sum, you just take a sequence of rows, sum it up, and return the total or the sum, the single value. When we are doing aggregate functions, we usually use a companion SQL clause, which is the group by. I've not done a video on group by, but in this video you understand how to use group by. Use group by with aggregate function. For example, we want to say sum per customer, then we'll group by the customer, or sum per vendor, you group by the vendor. I'll show you how we can do this. But first of all, let me demonstrate using the sum. but the sum is the first on the list. For example, we have a question from the database that says how much money is spent in total on each market date. For example, in the customer purchases, we want to say how much money do we spend in total on the database for each market date. So since we are saying for each market date, we are grouping by the market date. Remember that. So we can derive the query this way. You say how much money do we spend in total for each market date. You say market, want to see the market date, then you say sum quantity times cost to customer per quantity. You know it is price. Quantity times cost to customer per quantity is price. Then sum will sum all the prices to give you how much money you spend, total spend. We are doing this from the customer purchases database. Customer purchases. So since it's per market date, we are grouping by market date. I'll also order by market date. That is sort it so that you find it from the earliest to the latest. Order by market date. So let's just see the total spend for each market date. You see for April 3rd, 2019, the spend on the market is 405. On April 6th, 2019, the spend on the market is $549.5. And it goes down. April 17th, 2019, the spend was $493.5. So you can do this. If you want to see, for example, you want to see which market date had the highest spend. I know you can do it because I've tweeted this on the order by video, or you can check the order by video in the SQL playlist. Check the order by video. You can see how to sort it so that we'll see which market date had the highest spend. Good. Now that's for the sum inline calculation. What about the count? What if we want to do the count? When you are doing the count, you are saying find the number of rows that match a specific criterion. Let me give you an example from the customer purchases database. For example, here we'll see that we have market date, we have customer ID. I want to say for each market date and each customer, how many items were purchased in the customer purchases database. That is for each market date and for each customer, how many items did that customer purchase on that market date. It's an easy inline calculation. I'll show you how to do it here. So we'll say for each market date, we'll say I want to see market date, I want to see customer ID. They want to see the count that is returned. I will call it the items purchased. I will pulling this from the farmers market, the customer purchases. Remember, we are grouping by what are we grouping by? We say for each market date and for each customer. So we are grouping by market dates and customer ID. We can also order it so that it will go from the highest to the lowest to the highest. Market dates, customer ID. Now there's something I want to show you. Instead of using the names market date order ID, I could just say 1 here, 2 here. That is relative reference to give me the same thing. 1 here, 2 here. Do you remember this? I showed you in the order by video. and I'm using it here again, so you'll be familiar with relative reference. So this is the results table. So you see that for on the 3rd of 2019, customer 3 purchased only one item. 3rd of April 2019, customer 4 purchased only one item. 3rd of April 2019, customer 5 purchased 2 items. So this is the result set for each market and each customer, how many items were purchased. So this is how we use count. Now the next is what aggregate is average. The next is average. What does AVG mean, or average? It's just the mean across some rows. Give us the average or the mean. Now let's go to our database and see how we can apply this. For example, if we go to the vendor inventory table here, we could say give us the count of different products per vendor along with the average original price of the different products. The count of products per vendor along with the average original price. That's it. So this how we'll take in the table, we'll take the vendor. Since we are doing per vendor, we'll take the vendor, we'll see the vendor ID. We'll see the vendor ID. Then we'll say count of each of the different products. Since I say different products, we use these things here. I want to see the unique products per vendor. Different products offered. Then I want to see the average price of all these products. Average original. I want to see the average price of all these products as average product price. And we are pulling this from the vendor inventory table. Farmers. Remember, vendor inventory. So we are saying per vendor ID. So we'll grow by. Remember that per vendor. And I want to order by vendor too, so that it will go from the lowest ID to the highest ID. So you see we have three vendors. For vendor ID 4, the vendor offers only one product with the average price of 50 cents. Vendor ID 7 offers 4 products with average price of 3.8 something. Vendor ID 8 offers 3 products with the average price of 14.166 something. So that's how to answer that question. Now, the next is for the aggregate functions are the mean and the max. Yes, the mean and the max, and they are very self-explanatory. The mean gives you the minimum in a set of rows. The max gives you the maximum. I think every language has the mean and the max. There's no language I've not seen the mean and the max. Now let's go to our database. Let's see what question we can get. Let's go back to the vendor inventory table. We can ask, what are the least and most expensive item prices in the inventory of our 3 vendors? Since we have original price here, what is the least and most expensive prices that the vendors are offering? So we could state it like this. The mean is the least expensive, so we'll say mean original price as least expensive product. least expensive, then max original price as most expensive from vendor inventory, farmers market dot vendor inventory. That's it. So we'll get just the least expensive. The least expensive price is 50 cents. The most expensive is $18. That's it. So we are through with aggregate functions. The third method I would like to show to you is date functions. Date inline calculations. And I'll use the date add function and the date diff function to show you the date inline calculations. Date inline calculations just deals with dates. Now, date add. In the date add, you add an interval of time given as days, months, or years to a given date. For example, today is Wednesday, 25th of January. What if I say 1 week from today, what date will it be? You just put the interval of time in the date and you get the dates for next week, Wednesday, 1 week from today. Now, let's see from our table, customer purchases have a date. Let's say give a date 1 week from the date of a purchase. Give a date 1 week from the date of a purchase. How can we get this from customer purchases table? So I can say, show me the market date of the purchase, then give the interval. In SQL, in date add, you put an underscore between both words. And for the date add function, you first put the date column, then you put the interval you are specifying. I'll say interval 7, and with the unit 7 as 7 days later. So we are getting this from the customer purchases table. I want it to be per day. I don't want it to be, because a date can have more than one purchase, so I'll just group by market date, and I'll order it so as to put it in sorted order. Market date. So you see, 7 days from April 3, 2019 is April 10. 7 days from April 6, 2019 is April 13. So that's for date add. Now what about the date diff? The date diff function. In the date diff function, it gives you the difference between two dates in days. For example, if I say the difference between January 23 and January 25 is 2 days, that's what you use the date diff function is. Now how can we use the date? Let's see what table. Customer purchases table can help us. We can say calculate the difference between the first and the last purchase of a customer, giving a count of the market dates from that purchase. For example, we say we purchase something as the first purchase date, and then the customer purchased the last time as the last purchase date. I want to see the number of days between both purchases. Give me a count of the dates, not counting weekends. Then I want to see the number of days that has elapsed between both days, every other day, weekend included. So this is how I run the query. I want to see the customer that did the purchase, so I'll put customer ID. Then I'll calculate the mean, that is the the first purchase date. I calculate the first purchase date as first purchase. Then I'll do max the latest purchase date. Then I'll say give me the count of the number of market days in between. The number of market days in between. So we are doing 16 so that it will not see 2 April 3 and call them 2 days. But if they are 2 April days, call them just 1 day as count of purchase dates. Then I'll say the difference between both days. We say last purchase and give it the first purchase. Because the date diff just takes the 2 dates you are looking for the difference. So I'll give you the last purchase date and the first purchase date as days between first last purchase. So we are pulling this from the customer purchase purchases table. Since it's for each customer ID, you get it per customer. So I'll say for each customer ID. So this is the output now. You say customer ID first purchase was April 6, that purchase was October 10, the count of market days is 117, the date between the first and that purchase is 553. And this is how it goes. This is how it goes. So the count of days they made the purchase was 117, and the count of days made the purchase is 117, and this is how it goes. So you can see that ID2 has made more purchases than ID1, but ID1 and ID2 has the same days between first and last purchases. That's for dates. Now, the next we are going to look at is the fourth method is the case statement. The case statement is just for doing conditional calculation based on a column's value, or we can say it's the if statement of SQL. Case statement is just the if statement of SQL. Let me give you the syntax of the case statement. This is how the syntax of the case statement goes. It goes as case when a condition is true. You put then and give it a result. Or when another condition is true, put then and give it the result. If none of the conditions is true and you want an else, put else and give it the result. Then you end the case statement. Then you give it a name. That's just the syntax of a case statement. Now, how can we use a case statement in our database? Let's go to the customer table. You can see that customers have zip. Customer have zip code. First name, last name, zip code, customer ID. Let's see how the customer table is structured first of all. Let's see how we can make out a statement, a query from farmers market dot customer. I'll limit 10. So we can say, okay, given a zip code, is it local or non-local? For example, let's say 22801 is a local customer, and if it's not 22801, it's not a local customer. So we'll say if local customers have zip code of 22801, distinguish between local and non-local customers using a derived column. So we can distinguish between local and non-local customers using a derived column. So this is how we'll do if 22801 for zip code is a local customer. So we'll say select, I want to show the customer ID, then I want to show customer zip, then this is a case. We'll use a case statement for this. When I want to make sure it's customer zip, good, it's customer zip. When customer zip is 22801, then label it local. When or else, so I'm not doing any other thing, not local. Then I end the case, end as customer location type. I use customer location type. I'm pulling this from the customer table, farmers market dot customer. That's it. So you can see customer 22801 is local, 22821 is not local, 22801 is local, 22821 is not local. So you can see it's our if case statement, is our if statement in SQL. Now we are done with the case statement. The next is string functions. String functions are just text, as we all know it, and I'll demonstrate string inline calculations with length, concat, and substring. So for the length just gives you the length of a string, and that's just that. How do we demonstrate this? If we go to our customer table, I'd like to find what's the length of the first name, what's the length of the last name. So let's just do it. What's the length of the first name? What's the length of the last name? I'll show the customer first name, customer last name, then length, customer first name as length, first name, show length, customer last name as length, last name, from farmers market dot customer. So this is a demonstration of length. So of the length inline calculation. So say first name is Jane, second name is last name. Jane has length of 4, Connor has length name of 6, Manuel has length name of 6, Diaz has a length of 4, Bob is a length of 3, Walsh is a length of 6, and so on and so forth. Now the next string inline calculation I'll show you is concat. This concat. What we do in concat is just that we combine two strings in concat. Let's see be on the customer table. Let's say want the full name. Want to combine first name and last name to give the full name. We can use concat for that. So we can say customer first name, customer last name. Then we'll concat customer first name. If we combine without putting a space, we just give you incomprehensible stuff. So we'll put a space as full name. From farmers market dot customer. Yeah, see, so we get the full name. We take Jane Connor and get the full name as Jane Connor with a space between, and that's all this query. This query here was just doing. What this query was doing, just give you the full name of the customer with concat. You can play around with concat and see how it works. Now I've come to my last inline calculation, which is substring. What substring does is to extract a substring from a given string. It takes a given string and it extracts the substring. So let's play around with this. For example, I'm not going to go to a database. I'll just give you a contrived example. For example, we have the string hello world. Welcome to programming with SQL. What substring needs is you give it the string, then the next argument is the position you want to start your extraction. In SQL, strings are indexed from 1. In Python, strings are indexed from 0, but in SQL, strings are indexed from 1, so no difference. So we give the position 1. Then the next argument is the length of the substring. Hello is 1, 2, 3, 4, 5. 5 characters. So we'll give it 5 as characters. I will say as first 5 characters. So the first 5 characters is hello from the hello world substring. So this is where I've come to the end of my video today on inline calculations. I encourage you to download the farmers market database and practice the video from the farmers market database, and watch out next time for more videos from the Python Novice to Pro channel. Please subscribe to my channel and also like the video. If you subscribe, you keep getting more videos that I release. So do subscribe and do like this video. It encourages me. So thank you very much and have a good